For example, let's consider the region that is bounded by the graphs of y equals e to the x, y equals e cubed, and x equals 0, the same region we considered for the previous examples. Find the volume if you rotate about these two axes. First, y equals -2, and then x equals 10. Okay, first step is to sketch this out. It helps to have something to look at. Here's e to the x. Here's e cubed. And here's x equals 0. The region that these are boundaries of is that space right there. And our axis of revolution is y equals -2. So, when you're doing a volume question, you want to ask yourselves, which method do you use? So we have a gap here. Since we have a gap, we use the washer method. If there was no gap, we would do the disk method, but we have this definite gap in between our region and our axis of revolution. Next, think of which variable to use. Are you in terms of x or y? We have a horizontal axis of revolution, so we're in terms of x, which you can see if you sketch out just like one of the rectangles. Like this is one of the rectangles that we'll use to approximate the volume, and you can see that this is delta x. That's the change in x. Delta x leads to dx, which means x is your variable of integration. So the volume is going to be the integral from a to b, pi big R of x squared minus small r of x squared dx. So first the bounds. Now the bounds are in terms of x, and the bounds are where your region starts. We start right here at 0, and where the region ends. We end right there, which is at 3. And we know that because that's the x value where e to the x equals e cubed. X equals 3. And so we have the integral from 0 to 3 times pi. Big R. Now big R is the outside radius. Big R is the distance from your axis of revolution to the point on the region that's farthest away. So big R is the outside radius. It goes from the axis of revolution to the point on the region farthest away. So it goes that way to the farthest away point. And it's in terms of x, so it's the top minus the bottom. E to the third minus -2. E cubed minus a -2. Small r of x, this is the radius of the gap, which goes from the axis of revolution to the inside of your region. That's small r. So again, when you're finding your radii, start from the axis of revolution. Outside radius goes to the farthest point on the region. Inside radius goes to the closest point on the region. And you're in terms of x, so this distance is the top minus the bottom. That's e to the x minus -2. And now we got it. The volume is the integral from 0 to 3 of pi big R squared minus small r squared. And then you would plug that into some computer program to find the actual answer. When I give you a quiz or an exam, I'll use functions that are easy to integrate. Or I might just say, write the integral that gives the answer. And in that case, this would be the answer. So again, it's just the volume of the big cylinder minus the volume of the small cylinder. Pi r squared h minus pi r squared h. Part B, x equals 10. What we do for that one is we redraw our graph. Here's e to the x. Here's e to the third. Here's x equals 0. There's the region that we care about. Here's the line x equals 10. So again, we go through our questions. Disk method, our washer method. This is the washer method. We have that that definite gap between our region and our axis of revolution. Which variable are we in terms of? We're in terms of y. Why are we in terms of y? Because when you make your rectangles, this would be an example of one of those rectangles, and the base is delta y, because you're going a vertical change every time. Vertical is y, so it's a change in y. Delta y gives you dy. Dy means the variable of integration is y. So our volume is going to be the integral from c to d of pi big R of y squared minus small r of y squared dy. The bounds are where your region starts and finishes. So it starts at y equals 1, it finishes at y equals e cubed. Big R of y. Big R of y is the distance from your axis of revolution to the outside of the region. So it starts from the axis of revolution, goes all the way to the point on the region farthest away. Just focus up the camera. That's not there. There we go. When you're in terms of y, it's the right side minus the left side. So that's 10 minus 0, because we're in terms of y. Small r of y is the distance from the axis of revolution to the point on the region closest to you. Right side minus left side. Now we're in terms of y, so instead of y equals e to the x, we have x equals log y. And we have 10 minus log y, because the right side minus the left side. And now we have our integral. It's 10 squared minus 10 minus log y squared. And if I did ask you on a test to just give the integral that gives the answer, you would not have to do any more than this. There's no need to multiply it out and simplify. You're welcome to, but there's no reason to.